Welcome. This is lesson 72. We're going to be finding some derivatives of some important functions here. We will be looking at an exponential function other than e to the x, and then derivatives of logarithms other than natural log. And then we'll be taking a look at the derivatives of the absolute value of different functions. So let's jump into this. The first thing we're going to do here is we want to find the derivative of a to the x. So let's actually let y equal a to the x, and we want to find the derivative of this. Well, we are not familiar with finding the derivative of an exponential yet. The only thing we do know how to do related to that is if we could figure out logarithms. So what we can do is we can take the natural log of both sides. So we could do natural log of y is equal to the natural log of a to the x. And we know by the power rule, the x can come out front here. So we have natural log of y is equal to x times the natural log of a. Well, a is just some constant, so natural log of a is a constant. And now we can differentiate each side. So we're going to differentiate this. So differential of natural log of y is 1 over y dy. And the differential over here, it's just a constant times x, so it's just natural log of a dx. And we want to find the derivative, which will be dy dx. So we'll divide both sides by dx. And on the right side, that cancels. So we have dy dx, 1 over y dy dx equals the natural log of a. We want to solve for this. So let's go ahead and multiply both sides by y to get rid of this y here. And we see that dy dx, so we're left with dy dx on the right side, the left side, is equal to natural log of a times y, but when we find the differential of a function, we don't want a y over here. We want it in terms of x. So we come back here and we know that y is actually equal to a to the x. So we can take out y and put a to the x. And that actually gives us our derivative of the natural log, or a to the x, dy dx is equal to natural log of a times a to the x. And so if we have a function, an exponential, a to the x, 3 to the x, 7 to the x, whatever it is, we know that the derivative of that is natural log of a times a to the x. And then obviously if we had a function up here in the exponent, we would have to use the chain rule. So let's go ahead and look at how we can use this. Here is the rule for the derivative of a to the x. So nice and simple, f of x equals 17 to the x, find f prime of x. Well, by the rule we just came up with, we know that the derivative of an exponential is going to be natural log of the base, so natural log of 17 times this function, 17 to the x. And that's our answer. So the derivative of 17 to the x is natural log of 17 times 17 to the x. Over here, we're going to have to use the chain rule. So we have y prime is going to equal the natural log of 42, natural log of the base, times a to the x, so times 14 to the x squared minus 5x. But since there's a function within our function here, it's a composition of functions, we need to use the chain rule, so we need to multiply by the derivative of what's inside, which is 2x minus 5. And that's our answer. We could shift some things around a little bit, but there's not a whole lot of simplification we can do there. Now what we're going to do is we're going to find the derivative of log base a of x, where a is a constant. Again, we know the derivative of natural log base e of x, but we don't know it for anything else. So we're going to use our change of base formula we're going to change log base a of x into natural log of x over natural log of a. So when we want to find the derivative of log base a of x, we're actually going to find the derivative of using the change of base formula. We have natural log of x over natural log of a. And natural log of a is just a constant, so we don't have to use the quotient rule or anything. So we have natural log of 1 over the natural log of a, so we have our constant still, times, and we just take the derivative of natural log, which is 1 over x. And so actually the derivative of log base a of x is 1 over x times the natural log of a. So this is equal to this. And we're going to go ahead and use these. So both of these new formulas we just came up with, the rule for the derivative of an exponential and the rule for the derivative of log base a to the x, you need to know those. So here we go. Let's use them. We want to find dy dx. Well, as we look at this is just the sum of 2 logarithms, and so we can use our formula here. So this is just going to be 1 over x times the natural log of a, and we remember a is just the base here, so natural log of 42. And then we have plus, same idea here, we'll have 1 over x times the natural log of 10. And that's our answer. Coming over here, let y equals cosine of 14 to the x. Find the derivative in terms of x of y, is that what that symbol means. So this is going to equal, well, the derivative of cosine of something is negative sine. So we got negative sine of 14 to the x, but we have the chain rule that's going to be in effect here. So we need to take the derivative of what's inside. Well, the derivative of 14 to the x, that is not this one. That's the other one we just looked at, which is going to be the natural log of 14 times 14 to the x. So a pretty ugly looking derivative, but that's the answer. You have to use the chain rule. Derivative of cosine is negative sine times the derivative of 14 to the x, which is natural log of 14 times 14 to the x. All right, let f of x equals log base 9 of x squared plus sine of x approximate the slope of the tangent line to the graph of f at the point where x is equal to 1. So it says approximate the slope, so we're going to plug in a value towards the end here. So in order to find the slope, we know that we're trying to find the slope of a tangent line. That means we want to find the derivative. So let's do the derivative, f prime of x. And the main function here is a log base 9. Well, we just learned from the last slide, which we'll look at real quickly, that the derivative of a logarithm is 1 over x times the natural log of the base. So we will think 1 over x, well in this case our x is this thing, so 1 over x squared plus sine x times the natural log of the base, so times the natural log of 9. And this is a chain rule, so we have to multiply this by the derivative with what's inside, which is 2x plus cosine x. A better way to write this would, we could just put this in the numerator. So we have 2x plus cosine x over x squared plus sine of x. I just noticed that I forgot my x over here, so there should be an x here, times the natural log of 9. And now what we want to do is we want to approximate the slope of the tangent line when x is equal to 1. So we're going to put a 1 in here. So we're going to do f prime of 1. And you got 2 times 1, which is 2, plus cosine of 1. Whenever it's not mentioned, we are working with radians here. So cosine of 1 over 1 squared, which is 1, plus sine of 1, times the natural log of 9. And we could go ahead and put that in the calculator, and we would get 0.6278. And that's an approximate answer, so we could put a little squiggly equals here. Approximately equal to 0.6278. All right, so we are now able to take the derivative of logarithms with bases other than e and exponentials with bases other than e.